We had already studied refraction through a lens. Today we are going to study refraction through a prism. And we will be deriving the equation refractive index of a prism is equal to sin A plus D by 2 by sin A by 2, where A stands for angle of the prism and D stands for angle of minimum deviation. I'll explain what it is. This figure shows a ray PQRS passing through a prism ABC. And there are a few terms marked in the diagram. I, angle of incidence, R1, angle of refraction in the first phase, R2, angle of refraction in the second phase, and E, angle of emergence. And one more term, delta. Delta is the angle of deviation. So whenever you are doing a derivation, always there is mark for a diagram, a properly labeled diagram, and a small introduction. Okay, so this is the introduction. You can see this diagram in your textbook in figure 9.23, refer that. And the introduction is: consider a ray of light PQRS passing through a prism ABC, triangular prism, and the terms are I, the angle of incidence, R1, angle of refraction through the first phase AB, R2, angle of refraction in the second phase AC, E is the angle of emergence, and delta is the angle of deviation. Each term I will be explaining. Now let us see how do you draw the diagram. PQ stands for a ray falling on the prism, and I am marking QN as the normal. So this is the angle of incidence, I. PQ incident ray, N is the normal. So this ray of light is traveling from air into the prism ABC made of glass. What happens to this light ray falling from a rarer medium to a denser medium? It should have gone like this. Ingane pogandiya ray. What happens? It bends towards the normal. Moving from rarer to denser, it bends towards the normal. Instead of going like this, it bends like this and reaches the second phase AC. There again what happens? Let me draw the normal to this phase with the normal 90-degree line. So this is the normal, and this phase again it is moving from glass to air. So what happens? It bends away from the normal. So it moves out like this. And this is the angle of emergence. Angle of emergence എന്ന് വെച്ചാൽ എന്താ? പുറത്തേക്ക് ഇറങ്ങുന്ന angle. Angle of incidence and angle of emergence. And here we are marking R1, angle of refraction in the first phase AB, R2, angle of refraction in the second phase. Now let me explain what is angle of deviation. PQ is the incident ray, and I have marked in dotted lines how this ray was traveling. Ingane pogandiya ray. What happened to this ray? Prism ഇവിടെ ഇരിക്കുന്നത് കാരണം it came out like this. PQ എന്ത് പറ്റി? RS എന്നുള്ള ഡയറക്ഷനിൽ മൂവ് ചെയ്തു. So let me extend it this side. So what happens? This angle we mark as delta, the angle of deviation. When we studied glass lab, we had studied about displacement. Lateral displacement പഠിച്ചത് ഓർക്കുന്നുണ്ടോ? അതേപോലെ പ്രിസത്തിൽ ഇങ്ങനെ പോകേണ്ടിയ റേ ഇങ്ങനെ എമർജ് ചെയ്തു. അപ്പം ഇങ്ങനെ പോകേണ്ടിയ ഒരു റേ ആയിരുന്നു. ഇറ്റ് കെയിം ഔട്ട് ലൈക്ക് ദിസ്. ഇതാണ് അതിൻ്റെ ഡീവിയേഷൻ. ഇതാണ് ആംഗിൾ ഓഫ് ഡീവിയേഷൻ. ഇത്രയും ഡീവിയേറ്റ് ചെയ്തു. ഇങ്ങനെ പോകേണ്ടിയ റേ ഇങ്ങനെ പോയി. ഈ പ്രിസം ഇരിക്കുന്ന കാരണം ഈ ആംഗിളിനെ ആംഗിൾ ഓഫ് ഡീവിയേഷൻ എന്ന് വിളിക്കുന്നു. Now look into this diagram very carefully. AQNR. ശ്രദ്ധിച്ച് നോക്കിക്കേ. AQNR. is a quadrilateral. What do you mean by quadrilateral? A figure with 4 sides. 4 വശങ്ങളുള്ള ഒരു ഫിഗറിനെയാണ് quadrilateral എന്ന് പറയുന്നത്. Example, rectangle, square, all these are quadrilaterals. Now AQNR is a quadrilateral. ശ്രദ്ധിച്ചു നോക്കിക്കേ. In a quadrilateral, you have studied that sum of all the angles of a quadrilateral is 360 degree. Now in this quadrilateral AQNR, Q, angle Q അല്ലെങ്കിൽ angle AQN is 90 degree. Why? QN is a normal. Similarly, angle R or angle ARN is also 90 degree. Why? This is also a normal. So 90 plus 90. The opposite sides in the sum is 180 degree. So what about the remaining angle? Which are the remaining angles? Angle A plus angle N. ഇത് രണ്ടും കൂടെ കൂട്ടിയാലോ 360 minus 180. How much is that? Remaining 180 degree. ഇതും കൂടെ ആഡ് ചെയ്യുമ്പോൾ 90 plus 90 180 എങ്കിൽ ഇതും കൂടെ ആഡ് ചെയ്യുമ്പോഴും നമുക്ക് 180 കിട്ടണം. So I can say from quadrilateral AQNR, angle A plus angle N or angle QNR is 180 degree. Again look into the diagram. We have said that angle A plus angle N is 180 degree. Now concentrate in the triangle QNR. Which is triangle QNR? This one. ഈ രണ്ട് നോർമൽസ് വന്ന് മുട്ടുന്ന N എന്ന് പറയുന്ന പോയിന്റ് QR. So QNR. It is an inverted triangle. തലകുത്തി കിടക്കുന്ന ഒരു ട്രയാങ്കിൾ ആണ് QNR. In this triangle, you have studied that sum of the angles of a triangle is 180 degree. Which are the 3 angles of this triangle? R1 plus R2 plus this angle, angle N is 180 degree. Angle N is angle QNR. So R1 plus R2 plus angle QNR is 180 degree. So R1 plus R2 plus angle QNR equals 180 degree. So now we got 2 equations. From the quadrilateral AQNR, A plus angle N is equal to 180 degree. From triangle QNR, R1 plus R2 plus angle N equals 180 degree. So I am calling these two as equations 1 and 2. Observe these 2 equations very carefully. From equation 1, we can say angle A is equal to 180 minus QNR. ശരിയല്ലേ? Angle A equals 180 minus QNR. From equation 2, R1 plus R2 is equal to 180 minus angle QNR. So we get the right sides are equal for equation 1 and 2. So what about the left sides? If the right sides of an equation is equal, we can equate the left sides. Right sides രണ്ടും equal ആയതുകൊണ്ട് left sides നെ നമുക്ക് equate ചെയ്യാൻ പറ്റും. So from equations 1 and 2, you get R1 plus R2 is equal to angle A. കാരണം ഇത് രണ്ടും equal ആയതുകൊണ്ട് R1 plus R2 is equal to angle A. Call this as equation number 3. Okay. Now again look into this diagram. This triangle Q, let me call this point as M. Triangle QMR. ഒന്ന് നോക്കിക്കേ, triangle QMR. In triangle QMR, delta is an exterior angle. External angle ആണ് delta. We have already studied in the previous derivations that external angle is equal to sum of the internal opposite angles. These two are internal angles. This is the external angle. So delta is the sum of this angle plus this angle. Okay. Now what is the value of this angle? ഈ ആംഗിൾ എത്രയാണ്? This whole angle and this angle, ഐയും ഈ whole ആംഗിളും opposite angles ആണ്. What do you mean by opposite angles? If you have two lines like this angle and this angle are called opposite angles. But in this case, this angle is divided into two. So this was angle I, this was R1. So how much is this one? ഇതും സെയിം ആണ്. അപ്പോൾ ഇത് എത്ര ഉണ്ട്? I minus R1. So this much angle becomes I minus R1. Did you understand? Because I and the whole angle, they are opposite angles. So this much is I minus ഇത്രയും ചെയ്താൽ ഇത് കിട്ടും. So this is I, this is R1. So this much is I minus R1. Did you understand that? If you have understood that, the same case applies here. This is E minus R2. ഇയും ഈ ഫുൾ ആംഗിളും സെയിം, ഓപ്പോസിറ്റ് ആംഗിൾസ് ആണ്. So this E and this whole angle is the same. So this much is E minus R2. So this is I minus R1. This is E minus R2. So this delta is the sum of this angle plus this angle. How much is this angle? I minus R1. How much is this angle? E minus R2. So let us write down that external angle delta is equal to I minus R1 plus E minus R2. Let us open the bracket. I minus R1 plus E minus R2. R1 നെ R2 നെ ഒന്നിച്ചെഴുതാം. So I plus E minus R1 minus R2. I am taking minus common, minus of R1 plus R2. But we have already studied in equation 3 that R1 plus R2 is equal to A. So instead of this R1 plus R2, I can write it as A. So I am replacing this R1 plus R2 by A. Where did we get this? From equation 3. So instead of this, delta is equal to I plus E minus, instead of R1 plus R2, A. Let me call this as equation 4. Next I am drawing a graph between angle of deviation delta and angle of incidence I. So on the x-axis we have angle of incidence, and on the y-axis we have angle of deviation. Actually this is an experiment that you are going to do in the lab, okay, using prisms. Now when you draw a graph like this, it is observed that when the angle of incidence is increased, graph ആണ് angle of incidence കൂട്ടിക്കൊണ്ടിരിക്കുമ്പോൾ, what happens to angle of deviation? 30, 40 എന്ന് പറഞ്ഞ angle of incidence കൂടുമ്പോൾ angle of deviation is going down. It is decreasing. And at a particular point, that is when angle of incidence is equal to angle of emergence, after that point, when angle of incidence is increased, angle of deviation increases. So this is a graph. Except at this point, in all the other points, ഇവിടെ ഒരു line plot ചെയ്താൽ, you can see for one angle of deviation there are two angles of incidence. അതെന്തുകൊണ്ട് അങ്ങനെ വരുന്നേ? Because there is one angle of incidence and one angle of emergence. അതാണ് usual. But at some particular point, that particular point is when angle of incidence is equal to angle of emergence. ഇത് രണ്ടും ഈക്വൽ ആണ് ഈ പോയിന്റിൽ. ആംഗിൾ ഓഫ് ഇൻസിഡൻസും ഇത് തന്നെ, ആംഗിൾ ഓഫ് എമർജൻസും അത് തന്നെ. ആ പർട്ടിക്കുലർ ആംഗിൾ ഓഫ് ഇൻസിഡൻസിനെ വി കോൾ ഇറ്റ് ആംഗിൾ ഓഫ് മിനിമം ഡീവിയേഷൻ. ഓക്കെ, സോ വാട്ട് ഇസ് ആംഗിൾ ഓഫ് മിനിമം ഡീവിയേഷൻ? It is the angle at which angle of incidence is equal to angle of emergence. And angle of minimum deviation is represented by the letter D subscript M. Verum deviation delta ആണ്. Angle of minimum deviation is capital D subscript M. M താഴെ എഴുതുന്നു. So D, capital D stands for angle of minimum deviation. എന്താണെന്ന് മനസ്സിലായോ? At a particular angle of incidence, when angle of incidence is equal to angle of emergence, that particular angle of deviation is called angle of minimum deviation. Okay. So from this graph, what did we understand? When I is equal to E, angle of incidence equals angle of emergence, deviation D becomes capital D, called angle of minimum deviation. So what is the condition for angle of minimum deviation? Angle of incidence equals angle of emergence. I equals E. Condition for minimum deviation is I equals E. Angle of incidence equals angle of emergence. Now, when angle of incidence equals angle of emergence, R1 is equal to R2. I equals E ആവുമ്പോൾ R1 equals R2 ആകും. R1, R2 എന്തായിരുന്നു? ആംഗിൾ ഓഫ് റിഫ്രാക്ഷൻസ് ഫസ്റ്റ് ഫേസ് സെക്കൻഡ് ഫേസ് ആയിരുന്നു. I, E ഈക്വൽ ആകുമ്പോൾ R1 R2 ഈക്വൽ ആവും. ലെറ്റ് us call it R. So when we substitute this in equation 3, what was equation 3? Equation 3 was R1 plus R2 equals A. ആ equationൽ when you are putting R1 equals R2 equals R, R1 ന് പകരം R, R2 ന് പകരം R. So R plus R equals A. R plus R is 2R. So 2R equals A. Or R is equal to A by 2. So let us call that equation 5. Now from equation 4, we have seen that angle of deviation is equal to I plus E minus A. Okay, equation 4 ൽ നിന്ന് കിട്ടിയതാണ്. Again, when you are putting, നമ്മൾ എന്തായിരുന്നു പറഞ്ഞ condition for minimum deviation I equals E. I equals E ക്ക് പകരം we can write I and E are same. So instead of E also I can write I. So when I equals E, delta becomes capital D. Deviation becomes angle of minimum deviation ആകും. So I. Instead of E, again I. I plus I is 2I. So D is equal to 2I minus A. I am bringing this minus A to this side. So 2I is equal to A plus D. Or 2I is equal to A plus D, or I is equal to A plus D by 2. So we have derived two things. One, I is equal to A plus D by 2. And R is equal to E by 2. രണ്ട് ഞാൻ ബോക്സിലാക്കി ഇട്ടിട്ടുണ്ട്. So we have got R and we have got I. Iയും Rഉം കിട്ടിക്കഴിഞ്ഞാൽ we already know Snell's law. Second law of refraction. Snell's law, N is equal to sin I by sin R. ഈ equation we are going to substitute the values of I and R. What is I? A plus D by 2. What is R? A by 2. R is A by 2. So you know the value of R, you know the value of I. So in Snell's law, substitute the values of I and R. Instead of I, A plus D by 2, and instead of R, A by 2. And you get our required equation. N is equal to sin A plus D by sin A by 2.